Sobrang layo ko pa sa totohanan. Tingin. Hey, kailangan ko pa itaas pa pala to. Yeah. Medyo nagugulan ako sa sinasabi ni ChatGPT. So, okay, here. Let's see. Medyo all over the place yung kanyang sinasabi dito. Pero nag-gets ko naman na yung gusto niya iparating dito. So, parang lit kasi ng space ko sa table ko. Come on. Okay, we're going to use BP here, right? Let's do things a bit slow because somehow I'm a bit confused. So first, we will use BP to tokenize the training data input, right? Hindi na mahalaga si currency LI. Okay, yes. Step 1 is raw training text, BP tokenizer, the token ID. The sliding window does not work on raw words or strings. It works on the encoded token ID stream. Example, okay. Then sliding window uses the integer sequence pipeline. The text BP encode vector size token ID sliding window. So, dito na ako sa part na to. So, sliding window, input target pairs in the book. Okay, so gawa ko dito sa code. Ano ba yan? Ang laki kasi nung ano ko. Ano ba to? Late kasi ng table ko. Hirap pag nasa condo. Malit na kasi yung condo ko. Studio type lang siya. I'm still saving for a house and lot. Okay. Ito muna. Kailangan ko ng ano. Sige, pagka ipon ako pa para i-replace tong aking table. Alright, so here, so library ko tong token BPE encoding na to. So this will be my, and then gawa ko for sliding window. Sliding underscore window. Okay, window. So now, sliding window, what we are going to target init live. Then we will try to byte pair encoding. Is it tama ba to? natin yung path niya. Relative path. Tama. Cargo check tayo. Ayun, tama siya. Since nagda-download siya ng dependencies. Okay, so once we get it here, sabi kasi dito sa book is dang it. Clear ko yung desk ko. Alam ko na gagawin ko. Inaisip. Hindi na. Tanggalin ko muna itong mga annex. Bawal i-hide yung camera. Anyway. So dito, so here, I'm going to data sampling. Alright, so LLM, so I'll try to simulate this. So here in the sample, Python example, I will use the verdict. The verdict. Ato. So I just need this one. Copy this one. So this will be my training data. Okay. This is a good way to check kung gumagana yung aking BPE. Take this one. Okay, I think lagyan ko ng Tokyo. Cargo add Tokyo. Features, macros, test util. Feature macros. Qualify it's being activated for like Tokyo macro, test dash util macros. Okay. So, part na pala siya nun. Pati yata derive, no? Meron ba derive? Anyways. Yeah, I think pati serde. Cargo add serde. Ano ba yung mga nilagay ko dito? Seoul, Tokyo. Hindi ko na pala kailangan yung serde for now. Tokyo lang. May test.utils eh. Iloloko ako nito. Mukhang 52.3 test.util lang pala. Sorry, wala palang S. Okay. Now, let's do this. pub mod case. Thank you for the likes. FN test the verdict. So let content read file na lang na macro. Wala. Read directory, read to string. So read the entire contents of the file. This one. And then you just need a path. And then the verdict. The text. Expecting the verdict. So let's check kung nandito siya. Should be saan na ba ako? Oops, so what's wrong? Not found this system. Okay, wait. Ba't di niya makita? This is interesting. Not found? Paano ba siya? Saan ba siya tumitingin dito? Kailangan ko ata ilagyan nito. Not found message. Reads the entire content of a file. Mamaya mali yung path ko. That's the verdict. Tama. Yun ang absolute path na nga bibigay ko. Pag ito, wala pa din. Ayan. Okay, so we were able to load it. Now, training. PPE training. New. So this is my input. So which is the content. Okay, so now we need this one to be mutable. Shit, ano ba namang ano yan? Sakit sa tenga nung music sa labas. Yung bass. The vocabulary size. Oh no, this is kinda not good. So let's say 1000. The verdict. Shh. Medyo matagal yung tokenizer ko. Mukhang ditutok ko na siya matatest. Yeah, oh no, I'm seeing. Alright. 10 seconds. So medyo madami siya. Training size is 1000. Why? 21 KB lang to Good. We'll use the uploaded the verdict text that as the raw training text for data sampling. So it processes the... Okay, so here, vocabulary. Vocabulary was new. And then, weird. No, I'm using the type. This one, vocabulary, PPE vocabulary. So training result, that vocabulary, training result, that special tokens, vocabulary, that next step after creating So, I think pwede ko bigay siguro tong sample na to. I think mag-try lang ako siguro ng 100 vocabulary size. Bilis. Special tokens after training for final vocabulary size 100. Specialty tokens are consistent. That is clean. The learn merge rules also make sense for English prose. Okay, this means that organizers learning useful byte patterns. That is exactly what byte level BPE should do on prose. One important observation, vocabulary is still very small, only around 100 per token. This is fine learning, but expect many unknown fallbacks in another. Sure. Yeah, true. Now, sliding window, next step is not more BP training. So now you encode T-birding into token IDs, then can generate the input. I think this one, mukhang, I might need this one, get token IDs. Now, token IDs mapping. So I'll just need to return. I think kailangan ko lagay siya sa types, no? Now we need to replace this one. Token IDs. I think this one also. Oh wait, am I tripping or what? Ay, tama pala. I'm not sure if it was the right thing na I name it token. I think sa ganda kong token na lang, no? BPE token na yung pangalan niya instead of vocabulary. Oops, masyadong marami. No have, okay. That means your tokenizer can now convert, okay. So, sample. So next thing you need is not mapping, it's you need the encoded token stream of the whole. So, for example, shape. Oh wait, I don't understand this. Okay, paano ba to? So the next thing is you need is not the mapping itself anymore. You need the encoded token stream. Okay. One of the easiest intuitives. Huh. Then sliding window will work on the vector side. So that's next thing you need to. Can you elaborate this? Meron sa messenger, sira ata messenger ko. Sa token. Okay. Saan na ba tayo? Wait. Ano nangyari? Diba sabi ko elaborate niya? Okay. Yes. Let's separate the mapping from the encoded tokens. Token ID mapping is a dictionary. Your token ID's mapping is the lookup table. Okay. Alright. Then this mapping does not represent the book text yet. It only says if this type token appears, what ID, what trigger, what integer ID should I use? Think of it like your vocabulary registry. Okay. Encoded token stream is the actual text converted into IDs. Now let the actual raw text from the verdict text, which starts with I had always thought Jack Gisborne. So, okay. So I will use this one. Okay. So this one, no? So gagawin ko tong runtime. Okay. So let's try. This will be my runtime. EPE ranta. Oh, okay. Hindi ko pa pala nababago tong runtime. Okay. So input ko is Training data. So, training result that. Okay. Ito lang pala. Alright. So, runtime that. Nito na pala yung run. Enable to execute runtime. Okay. Okay, so this one. This is my runtime. Ano ba ginagawa ko? Is this still sliding window? And then difference is one sentence token ID mapping dictionary. Sliding window does not use the mapping directly. It uses the actual sequence of the token IDs. So then it creates training samples. Okay, now this runtime tokens into token IDs using your mapping. Okay, and then alright, so here runtime token IDs. Runtime writer. Vocabulary that get token by token get ID by token. So this one should not be item. Oops, wala pa pala. Alright. So runtime token IDs is this one. Okay. Now we can finally talk about signing. Yeah, okay. So we train the data using the verdict.txt so we can have the tokens, and then we will convert those tokens to token IDs, and then we will have an input, so runtime encoding to get the ano ba yung kailangan natin? What's the proper way to describe this? Okay, so convert the runtime input to a token and then convert it to token IDs. Now we will use the token IDs. Encoded text. Gets. Okay. Now think of it as one long token tape. Okay, the model does not train directly on the whole tape, but we get it. Supposedly, max length 4. Okay, so dito papasok yung context 4. This is where context based on the book. Context length. Context size. Size. Use size. 4. And then I'm using Rust programming language. But the one that I'm studying in the book is written in Python. So I'm translating the Python example Python codes into Rust. So I'm not really reading or following the entire book. I'm just getting the insights and then I let ChatGPT do the thing to explain it to me. Dahil ko sinabi. I said a lot. The only question is what language. Anyways, so my input encoded text is then target. Okay. 0 to 4 max length. Okay, let's see. Input and then context size. Sorry, this one. Runtime. Wait, I don't. Okay, runtime result and then get encoded text. Okay, encoded text is the convert tokenized one. Okay, I mean the one that's already converted to tokens. So alright, so meaning of this one is context size is 0 that context size, and then we will slide it. Runtime ID set get. So let's say 1, then context size plus 1 then. So let's see a bit something like this. Input. Target. So 86 and 4. Okay, we got it. Then the target is the same sequence shift in 1 token. So, alright, so meaning given boss, that is the core training format for GPT style next token prediction. Okay, so I can still understand what's the point of this sliding window. Again, target input shifted by 1. With max length 4. I'm still not getting the purpose of this hiding window. Turn one lone token sequence into many training examples because the model cannot learn just a file. It needs many small examples. Given this token, predict the next token. You currently have one long token, okay? This represents text like BOA, beginning of string I had always. This is just one long line of token IDs. The model needs training samples. What the model is trying to learn. Example text I had always. The model should learn. So the training must be arranged as I'm still I need the whole because a transformer has a fixed context size. For example, you may configure that means the model can only look at 4 tokens. Okay. So you must cut the book into chunks. That cutting process is sliding window. Why sliding? Because the window moves across the token string using token IDs. With max text for window 1, window 2, window 3. The window slides one token forward each time. The main purpose, sliding window creates many examples from one text. From one token stream. Parang nagsasampling siya. So instead of one big file, you now have many training rows. The simplest mental model, think of bring the flashcard. You create flashcard BOS. But for GPU training, we practice into fixed token arrays. That is sliding window does. LM training by predicting the next token, but they need fixed size input target examples. So we convert one long token into many. Okay. So it's like since Perimeter tries to generate many training samples from one long encoded text. Okay. Training data token stream. In your case, bird. Okay, sliding window. So, okay, gets. Max sliding window. So yes, the goal is to maximize useful next token prediction samples, but that samples are not random, they are structured overlapping slices. Batch size and then target, no? Medyo matinding mental model to. Medyo masakit siya sa ulo. Meaning the number of tokens per sample is called context length, max length, sequence length. Okay. So means every input sample contains exactly 4 token IDs. Using token stream, a single sample is token that has 4 tokens. Input shape T. So the number of samples processed together, sample batch size, means you're processing training samples at the same time. Wait. So, yung context lang ko, which is ito, context size ko. So, this is the type T variable. Then, B means the batch size. So, number of samples. So, if you group these 3 samples there, that is a batch. Okay. Meaning, 3 rows per token rows. Okay, sample 0. Sample 1. So, for ito yung rows, no? So, token 1, token 2. So how many row samples, how many token each row input? Keep it that you have both input and target. Each row is the matching input shifted by one token. Imagine you're giving a model quiz cards. Number of tokens in each quiz card. So you give the model one quiz at a time. You group several quiz cards together. Yeah. Okay. Means 8 quiz cards, each 4 tokens. Each with 4 tokens. Okay. So parang anong purpose of
na makita ang inyong mga ngiti, makita maya yung ama kayo ay mag-alamano.
the batch exists because training one sample at a time is inefficient. The purpose is instead of holding this, we do this. Then the group is the batch. Without batching, suppose you have one sample. Too little work for GPR parallelism. It works like so. Now suppose, okay. I think mag-make sense to once na tapusin ko muna to. Main reason hybrid patient. PS are designed to do many similar operations. Okay. Because GPT's LLMs are trained to become good at this task. That sounds simple, but it forces the model to learn language structure. Text natural example on the I always thought Jack Gisborne. If the model says I had always thought Jack, as a reasonable text next token is something Gisborne, so the training task becomes input. Okay, target Gisborne. The model learns pattern like grammar, spelling, names, punctuation, and style and meaning. By repeatedly solving this prediction, your uploaded training text begins with the same sequence. We do not manually label the data, but the language model in text already contains its own labels. So pattern matching lang talaga siya. So the target is just the same as text shifted by one token. So why this creates intelligence like behavior? To predict the next token well, the model cannot just memorize letter. It must learn something. So predict next token is the training objective, but the side effect is learning compressed statistical model. That is why token prediction is not to generate long text. Think of this as stream predictor. You have a token log stream. It becomes good at predicting the next event. If it had learned the structure of the stream, the LLMs do the same thing except the stream is tokenized text. Okay. Next. Okay, so sa sinabi na nga pala niya dito. Let's guess. Okay. So how does LLM response? What ano ba parang it doesn't make sense. A basic pattern matching. Hello, hi. LLM does something more flexible. Given this token, estimate which next token is best. LLM does not store one exact rule forever. Each during training, it adjusts millions of ways so that when it sees content, it produces a private distribution. Probability, so that it chooses the token using decoding logic. So the model response is not I found next placement. Based on the context I computed, these next tokens are likely. So predict answer, instruction, following pattern, syntax, predict code, predict explanation. This is interesting. Oh. May tatanong ako kay GPT. I'm currently studying I was thinking of creating a small model for Rust crates. Do I need a big GPU for it? No, you probably do not need a big GPU. I mean, already a small model of Rust crates. That's practical path is usually. That means your app searches relevant crates, doctor, and swing call algorithm is much cheaper and more accurate for specific. So let's say, how do I create a basic axiom route with shared state? For this, you can use your current machine, your mainly. So some guy estimate 60G plus B around. That changes the problem. You're not trying to make a Rust coding model. You're trying to make a semantic crate search model system, something like. Definitely do not need a big GPU. You need a closer to search recommendation system, not a custom LLM. The model does not need to generate code. It only needs to understand that I need a async crate. It is semantically create. So you need probably not embeddings, not fine tuning. The core model is you need an embedding model. Convert it to text to vectors, and each crate also get embedded. So let's say I need a crate for async. Then the LLM will suggest Tokyo, Mio, or something. Should be build high quality semantic. They probably need an asynchronous suggest as crates. That is important details in Tokyo are not the same cut yet. For this project, the LLM does not need to know everything. It can be used as an intent interpreter and explanation layer. Yes, that's what I'm trying to say. Goal is to create a LLM, create a model that is trained on great documentation, but not necessary the documentation. I mean the source code, not only on high level documentation. Train a model, adapt a model to understand ASCII document at a high level. That can be done. Because I will do multiple models, like large model, let's say 14B, small model generates a plan, then identify what traits it needs. Query or create the library based on receives the creates description and try to recommend. Yeah, multimodal. I think mas maganda nga to. Probably I fit it with documentation via Rastox or whatever. Yeah, I think mukhang ito yung magandang goal. This is a good goal. Okay. I'm getting this one. So yeah, what is Rust? Blah, blah, append. Okay. In your current pipeline, so the model is not memorizing one, so it learns a compressed key mental model. Ano ba yung question ko dito? So it's like a pattern match. How does the LLM respond to it? The joining train adjusts billions of miles so that it senses a context, it produces a probability distribution over the vocabulary. Then it chooses one token using decoding logic. So the model response is not in this way. I can have an updated model of grades because large coding models sometimes have outdated grades. Yeah, that's exactly what is wrong. Is large coding model can be outdated because their grade knowledge is frozen around their training cutoff. For us, this is a problem because grades change quickly. Your design solves that by separating reasoning from grade knowledge, the betterment of model. Okay. So where the intelligence goes from? I think I can use this for developing my own class crate. Okay, this is good. I'm getting excited. Tiny transformer. Okay. Okay, let's get back to the study. What's next? Okay, so I just need to. But what if I reach the uh dun papasok yung ano? Dun ba? What is the behavior if since it's sliding, most likely it will hit the out of bounds. How do I handle that? Is it bad? You can hit unless you stop correctly. For the basic book style sliding, usually do not use pad yet. You simply stop before the window begins. Okay. Yeah, kasi ganito yung may logic niya. So the highest probability index is because the target ends at it. Therefore, the safe condition is okay. So i-skip ko siya. So length is n if target context is 4, then the last valid start index will be 22. So valid rules are wait, hindi ko na-gets yan. So the valid values are, so last samples are result. That works because index is 26. So stop before that. Okay, so skip. So okay, kasi nga let's say yung my runtime is just small. I see. I think I'll stop on this one now. I'll do the do I stop now? I think I'll do this one. Ande? Bukas na lang. Friday naman bukas eh. So I have more time tomorrow. So I guess that's it guys. So thank you and see you on my next stream and bye bye.